Right, okay, nice big problem here. Okay, some charity event. Determine the fixed costs for the entertainment. Now, fixed costs are those things that don't change. I mean, if it costs you $5 for every person that comes in, then that changes. 2 people, $10, 3 people, $15. That's changing depending on how many people. Now, fixed costs. So, student bands, $200 each, that's $400, $1,000 for food, 200 paper products, 100 for posters, blah blah. That's $2,200 if you put it in your calculator. Okay, add all that stuff up, $2,200 is the fixed cost. Now the total revenue is the money that you're getting from the people coming to this charity event. Okay, now the quick way of doing this is 400 students attend and each buys a raffle ticket. Then if each student donates $10 and also buys a $1 ticket, then every student is basically going to be bringing in $11. Okay, so every student bringing in $11. So 400 students, okay, it's just 400 times 11. Okay, that's what you're bringing in, because each student is going to buy a lottery ticket for $1 and pay $10 donation, so $11 each, and that is $4,400. Okay, so $4,400 is what you get from the students. Now remember, I think we said total fixed costs, what it's going to cost you is $2,200 to set up this event. So it looks like you're going to make a profit of $2,200. Okay, if you get $4,400 and you have to spend $2,200, there's your profit. Okay, now let's look at some more questions though. Determine the profit. There it is. Remember that was $2,200 because it was $4,400 what you're getting in from the students, less all that money you have to spend on everything for setting it up. So that's going to be $2,200 profit. Right, so as an equation, now think about the total revenue for the event. You're always going to get $11 for every student. It's just this. So I don't know, I can say that the revenue, revenue, profit. Now I'm going to call this, I'm going to call the revenue. Now if you do it proper function notation, the revenue for these n students, okay, it's just this, 11n, because it's $11 for every student. That's the revenue equation. Okay. Now the profit Pn is going to be what you get in minus what you have to spend. All right. Remember, which was the $2,200. Now that's fixed. So your profit is always going to be 11n, what you get in revenue, minus $2,200, which is what you always have to spend. Okay. So if we write it properly, profit P of n equals that. There you go. Okay, that's it. That's what profit you're going to make. What you bring in from the students, $11 for every student, minus the fixed amount of $2,200. So you need a lot of students. You know, we can always work out later what we need to make a profit. But you know, super replacements for n. Is it meaningful to have a half? What, half a student? Or -3? No, it makes no sense. You're going to either have no students or whatever at the maximum capacity. I think later on it says 650 students is the maximum. So those would be the practical domain. No students show up, or a maximum of 650 if that's the maximum that the room can take, the ball. Okay, so that's kind of practical domains, what you can use for n, the number of students. You're not going to have 3 million, all right? Okay, complete the table. So for no students, right, remember this? Remember the equation. We had 11n, $11 for every student, minus the $2,200 that we have to fork out, we have to spend, sorry, fork out on my English expressions, okay, on the event. So that, remember, was the profit equation. So we're going to use this equation to find out, right, if no students shown up, you've just lost $2,200, okay? Because when n is 0, it's just minus 2,200. When n is 50, right, what's 11 times 50? I think that's 550. Okay, so if 50 students show up, you'll get $550, but still less $2,200. You're still making a loss here. All right, so I might need a calculator for that. So 2200, 550. So you're making that's still negative 1650. So negative, you're still making a loss. Okay, I think you're going to make a loss for a while here. I'm going to try, I know that's going to be a loss, I'm feeling that's going to be a loss. I'm going to try 200 students. Let's see what 200 students is. Okay, so for 200 students, I'm going to put n equals 200 into the equation. Right, so it's 11 times, that's, oh wait a minute, I think this is going to be the break-even point. That's what 11 times 20 is, isn't it? Yeah. Sorry, 200 students. Less the 2,200 that you have to spend. Right, so you don't make a profit, but that is what we call the break-even point. Okay, you need at least 200 students just to break even. After that, everything's a profit. We already did the 400 one. Try 300. Again, that's going to be $3,300 that you will make at $11 a student, less the 2,200. You'll make an $1,100 profit. Okay. And so on, and that's it. Now the average rate of change between consecutive data pairs in the table is, remember, it's just the difference in the y's, which is the profit, over the difference in the x's, which is n in this case. Basically it was saying, okay, remember this? That's the x, that's the y. Okay, so I'll use these 2 points here to make it easier. Okay, right. Okay, so the change, we go up by $1,100 up the y-axis if we were graphing this, and we go along the x-axis 100. So that is my average rate of change. Now that's going to be for every, you do that everywhere, it's going to be the same. It goes up by the same amount each time. Just try it any way you want on that. It will always be 1,100 over 100. Okay. Now that, if I do the division, is 11. The average rate of change is 11. Which means $11 for every student, okay? But look, lo and behold, get ready for this. That is the number here, okay? So we're going to kind of talk about that later. But yeah, the average rate of change, or the slope, is that 11, which is already in the equation, okay? So that's kind of not magic. We'll kind of discuss that later. Is profit a linear function of the number of students? Yes, it is, because if we were to graph this, it would go up by $11 for every student. If I was to graph that, it'd be a nice straight line. Okay.